Hello everyone, thanks for watching. Internal energy is not some weird abstract concept. It actually has a real meaning, and by the end of this video, you'll have a strong picture or understanding of what internal energy is. So when your prof is talking about it in class or you're solving problems that involve internal energy, you'll really know what it's talking about. So what is it really? Well, its definition is that it's the total energy within the system. And the key word here is within. So imagine we have a soccer ball, that's our system. This is our system here. And the system is moving to the right or to the left. Well, this movement is not internal energy because the whole system is moving together. This is considered external energy. Internal energy is the movement of the atoms and the molecules within the system itself. So if we dive deep inside the system, it's the energy within that. Well, what is that energy? Well, there can be kinetic energy, translational energy, the energy due to movement, 3D movement of the particles, molecules, atoms within the system. There's also potential energy, so attraction or repulsion between molecules and between atoms. There's also rotational kinetic energy. Again, any kind of movement will have an associated kinetic energy. There's vibrational energy, so within the bonds between atoms, and if it's vibrating, then it has kinetic energy due to movement, and then potential energy that's being stored, that's attracting and repulsing the atoms together. So kind of like a spring going back and forth there. There's also rest mass energy and electronic or orbital energy between the electrons and the nuclei of the atoms themselves. Now, all of this is comprised of the internal energy. Think about the movement of the atoms, the movement of the molecules, the movement within the system, and also any kind of energy that's any kind of potential energy that may have attractive or repulsive forces between the molecules or between the atoms or anything like that. So that's internal energy, and if you have that in your mind, it's really going to help with thermodynamics. Now in thermodynamics, we really mostly care about the kinetic energy and the potential energies of the system, within the system, not so much the rest mass or the electronic or the orbital energy. So our internal energy is the total energy within the system. Keyword is within, and it's a state variable. I have a whole video explaining and describing state variables versus functions. You should definitely check that out. But essentially, a state variable describes a property of the system. So for example, if we have our system in one state, say this is state 1 here, and we'll call this having low internal energy, versus say a higher state where if we heat it up, these molecules are now moving faster. Maybe they've transitioned from a liquid to a gas. They now have a high internal energy because they're moving faster. Mathematically, the internal energy is equal to the sum of the kinetic energies and the potential energies of all the constituents within the system itself. Now that's a lot, but in thermodynamics, we really only care about energy transfer. We care about changes in energy mostly. So this delta U is what we care about. We don't care about internal energy itself, like the actual value of U. And because internal energy is a state variable, the change in internal energy is equal to the internal energy in the final state minus the internal energy in the initial state. And we could also write this as an integral where the change in internal energy is equal to the integral, so all the sum of all the little infinitesimal changes of internal energy from the initial to the final state. Alrighty, so to wrap it up, the internal energy is the movement within the system. So think of the kinetic energies of all the atoms and the constituents, And it's the energy, like the potential energy that's held between the molecules, between the atoms, the potential energy stored in chemical bonds or the movement due to the chemical bonds. It's due to the energy from mass, although we don't care about that as much in thermodynamics unless you're dealing with an open system usually. And any other energy that you might think of within the system, and you should be good for conceptualizing internal energy. I know thermodynamics is not easy to learn, but little by little, as you grasp these concepts, it's just going to make a lot more sense. Focus on the fundamentals, spend a lot of time on these introductory concepts and terms, and it's really going to help the rest of your thermodynamics.